All right, we have a video today that involves 10 practice problems. So go ahead and solve each of the problems with me, and there are 2 checkpoints. So during the checkpoints, you're going to pause the video, solve them, and then we'll check those when we get back to class. So good luck on this. It's a review of compound inequalities. All right, so let's take a look at the first problem here. So go ahead and copy this down. Number 1, c is greater than -1 and c is less than -6. Well, this is an and, so what we were looking for is we want to know where these two intersect. We want to know where these two inequalities. So remember, we're going to put the numbers on the number line. So -1 and, whoops, I have to put the -6 over here because they have to go in order from smallest to largest. So -6 is smaller than -1. So on the number line, technically, the -6 is there and the -1 is over here. So now that I have that, I'm going to graph each one. So the first one says c is greater than -1. So I'm going to come to -1. I'm going to come up above it, just do my little helper graphs. It's going to be open and to the right. And remember, I draw as far out as my arrowhead down here. And my next one is c is less than -6. So here's -6, and I'm going to go this way. So c is less than -6. Now, since it's an and, I need the intersection. Well, they don't intersect. There's no place where there's 2 lines there. So the answer to this is no solution. All right, moving on to number 2. This is an or. So on an or, I bring both of my graphs down. So I have the numbers 4 and -3. So I place those on the number line. So I'm going to put the -3 over on the left side and the 4 on the right. Then I'm just going to graph them one at a time. So I start with the first one. A is less than or equal to -4. Well, I know it's going to be a solid dot because it's got the line under it. I'm going to go to the left. My next graph is A is greater than -3. So that's an open circle, and I go to the right. Now I have to bring everything down because I'm happy if A is less than or equal to 4 or if it's greater than -3, and that covers my whole number line. So when I bring everything down, everything's covered. So for my final solution, I'm going to have everything shaded. There we go. All right, for the writing the compound inequalities, whenever you have a single solution set like this one, where it's all contained, this is the one where you write your 2 numbers in order, and then you put the variable in between, and your inequalities are always facing the left. Now, since they both are colored in, they both get a line under it, and you're done. So those are the easy ones. Whenever you see those, that's what you get. Because what this means is x is greater than or equal to -2, and x is less than or equal to 3. But that's the simple way to write it. Now let's look at 4. Since there's a space there, this is an or, so I just do them each separate. So for this one, I have x is less than or equal to -4, and then I say or x is greater than 4. Done. Well, now that we know how to graph these, the next step is we're going to have to solve them and then graph them. So no big deal. So let's just go ahead and solve this. So I'm going to solve them separately. So I'm going to divide both sides by 4, and I get x is greater than or equal to 3. And this one, I'm going to subtract 2. So I get 6 is less than or equal to -x. Then I have to divide by -1. And when I divide, I flip my inequality. So that's what I have. Now, remember graphing that, we've got to be careful because this is really the same as x is less than or equal to -6. So these are the 2 things I'm graphing, and it's an and, so I need to know where they intersect. So I'm going to put my 2 values on the number line, so I have -6 and 3, and then I just graph them one at a time. So I start with the first one. X is greater than or equal to 3, so I put a dot and I head to the right. I colored it in because there was a line under it. And over here I have x is less than or equal to -6. So again, I have a dot that I color in, and then I shade to the left. Now I need the intersection. Well, there's no intersection because there's just big space in between them. So the answer is no solution. Moving on to number 6. Copy this down, please. 2x plus 3 is less than 5, and negative 3x minus 6 is greater than 12. All right, let's go ahead and solve this first one. I'm going to subtract 3 from both sides. So I get 2x is less than 2. I divide by 2. I get x is less than 1. Okay, moving on to the other one, I'm going to add 6 to both sides. And I get negative 3x is greater than 6. I divide by negative 3. Uh-oh, I divided by a negative, so I got to flip my sign, and I get negative 2. All right, so now I'm going to put my two values on the number line. So the smallest one goes on the left. So that one, the negative 2, goes on the left, and the 1 goes on the right. So now I'm going to graph them one at a time. X is less than 1. It's got an open circle shaded to the left. X is less than negative 2 is also an open circle, and it's shaded to the left. Now since it's an and, I need to know where do they intersect. So that means where are they both above the graph? Well, this is the point that starts the intersection, and right here is where there's 2 lines above it, so that's where they intersect. Because if I look in this space right here, there's only 1 line above it, whereas here there's 1, 2. There's 2 lines above it, so that means they intersect there. Okay? All right, so let's look at number 7. So number 7 is also an and problem, and so I'm going to start out by solving both of these inequalities. So the first one has a fraction in front of my variable. Well, I know what to do. Whenever I have a fraction, I multiply both sides by the reciprocal. So the reciprocal is negative 3/2. So I'm going to multiply both sides by negative 3/2. Well, the 3's and the 3's cancel, the 2's and the 2's cancel, the negative cancels. But I multiplied by a negative, so I had to flip that. Now remember that rule is if you multiply or divide by a negative, you have to flip your inequality. All right, so now I'm going to go to the other side. I have a negative times a negative, so that's a positive. And then 12 times 3/2. The 2 and the 12 cancel with a 6, so that gives me 18. So there's my first one. X is greater than 18. And now I need to solve the one over here. So I'm going to add 5 to both sides. So I get 2x is less than 4. Divide by 2. I get x is less than 2. So there's my second one. Alrighty, we're going to graph these. So remember, the smaller number goes on the left, the larger number goes on the right, and then I graph each one. This one says x is greater than 18. So that's an open circle shaded to the right. X is less than 2 is an open circle shaded to the left. And I want their intersection. Well, there's no intersection because right here, there's only 1 line above this portion of the number line. Here, there's nothing above this part of the number line, and here there's only 1 line above the number line. So there's never a time when they intersect. So the answer to this is no solution. All right, number 8 is also an and. So I'm going to do each part separately. So I'm going to start on the left. X minus 5 is greater than or equal to negative 5. So I'm going to add 7 to both sides. These cancel out, and I get x is greater than or equal to 2. Now I move over to the right, and I have x minus 6 is less than or equal to 1. So I add 6 to both sides, and I get x is less than or equal to 7. So now I have my two inequalities, and it's an and. So what I'm going to do is I'm going to put my numbers on the number line. The smallest one goes on the left, so there's the 2. My larger one goes on the right, so there's my 7. And then I'm going to make my helper graphs. So for x is greater than or equal to 2, I'm going to have a solid dot because I color it in because there's a line under it, and I shade it to the right. For x is less than or equal to 7, I'm also going to have a solid dot because there was a line under, and I shade it to the left this time. Now, what I bring down to my final solution is the portions where there's 2 helper graphs above the graph. So let's look at each piece. So here there's only 1 line above my graph, but here there's 2 lines above it, and over here there's 1. So the only thing I bring down is this part in the middle, but then my dots have to match. So above my 7, it's a solid dot, and also above the 2 is a solid dot. So that's my final solution. All right, we've arrived at check part checkpoint 1. Go ahead and pause the video and solve this, and we'll check it in class. All right, moving on to number 9. These are the OR graphs. All right, so let's still go ahead and solve because it's always our first step. So in order to solve, I have -1 plus x is less than 3. I need to add 1 to both sides. So I get x is less than 2. Okay, now I'm going to solve the one on the right. So I have -x is less than or equal to -4. Well, I don't care about -x, I care about x, so I have to divide both sides by -1, and remember when you do that you have to flip your inequality symbol, and then I get a +4. So now I have my two solutions, but this is an OR. So the way that I graph this is I still put the smaller number on the left, and that's going to be my 2. The larger number goes on the right, and that's my 4. So I'm going to start with my 2. X is less than 2 is going to be an open circle shaded to the left. For my x is greater than or equal to 4, it's going to be a colored in dot because there was a line under it and shaded to the right. Now for my final solution, I bring everything down. So this is part of the solution. So open circle shading to the left, and then closed circle shading to the right is my final answer. Because the OR means you're happy with either OR. So I bring them both down because that's part of my solution set. All right, moving on to number 10. I have 2x plus 4 is greater than 16, or 2x minus 1 is greater than 9. So again, I'm going to start by solving each of my inequalities. So for the one on the left, 2x plus 4 is greater than 16. I begin by subtracting 4 from each side. So I get 2x is greater than 12. Divide both sides by 2. I get x is greater than 6. Okay. Moving on to my other one, I have 2x minus 1 is greater than 9. I add 1 to both sides, and I get 2x is greater than 10. Divide by 2, divided by 2, I get x is greater than 5. All right, now it's time to put them on the number line. So I put my smaller number on the left, which is the 5, my larger number on the right, which is the 6. And then I graph them both. So for x is greater than 5, it's an open circle because there's no line under it, and I shade it to the right. For x is greater than 6, it's an open circle at 6 and, whoops. It's an open circle at 6 and also shaded to the right. And now for the OR, I just bring everything down. So when I bring everything down, I end up with this open circle here, and then I color everything because that open circle at 6, he gets colored in because there's a line above it. So it's everything. Everything's part of my solution for the OR. All right, we have reached checkpoint 2. This is the very last slide. So go ahead and copy this problem down and solve it, and then go ahead and do the graph, and we'll discuss this during the next class.